Alright, let's have a look at this question. It's got a few pieces. We've got this expression over here, and we're asked a few questions about it. First of all, how many terms are there? Now remember, with a term, every time you see a plus or a minus sign, usually that indicates the start of a new term, plus the term at the front. So what I'd suggest is you just split it like this, for example. This part here, this 4x squared, that's a term. Then you can see at the minus sign, I split it, but split it in front of the sign. So every time there's a sign, I'm going to split it there, I'm going to split it there, I'm going to split it there, there, and there. So I would say there are 1, 2, 3, 4, 5, 6. I'm going to go with 7 terms in that expression. Now, I think in class we did something a little bit different, but I would give you that answer, or I'd give you the one we did in class. Both have been correct. But in this case, every time I see a plus or a minus sign, if I split it, it's a term. What is the coefficient of y? Okay, let's just get rid of all that. Okay, so the coefficient of y is the number in front of the y. So if I have a look, there is my term, my plus y. There's no number in front of it, but remember, whenever there's no number, there's actually an invisible 1. So in other words, that's the same thing as plus 1y. So I would say the coefficient, in other words, the number in front of y, is plus 1. So let's go with plus 1 for that. Actually, let's get rid of all that. And let's put the answer back in. What do we have in the first one? We had 7. What is the coefficient of x squared? So the x squared is up here. The number that's in front of the x squared, because that's what coefficient means, is 4. But we want to include the sign. So in this case, it's not a negative, so we assume it's a positive. It's a plus 4. And what is the constant? The constant is the number on its own that doesn't have a pronumeral with it, because it can't change depending on what the pronumeral is. It's just constant, and it's constantly plus 12. So in this case, it's plus 12. The last part of the question says find the value if you're given x equals 2, y equals 3, m equals 4. This just becomes a substitution question. It's a little bit of a messy one, but we'll go through it and see how we go. Remember, with substitution, I've asked you guys to put a bracket wherever you see a pronumeral. So I'm going to rewrite the expression, putting a bracket everywhere I see a pronumeral. Minus 2 outside of bracket, minus 3 plus 2 over bracket, bracket. Oops, sorry, that should be bracket plus bracket, minus 2 outside of bracket over 3 plus 12. All right, I've just rewritten the whole thing, but I've put brackets in where there were letters. And for the corresponding x, y, and m values, I'm going to put them into the bracket. So wherever I saw an x, I'm going to put a 2. So 2 there, 2 there, a 2 there, a 2 there. Wherever I saw a y, I'm going to put a 3. So that gives me a 3 there, a 3 there, and wherever I saw the m, I'm going to put the number 4. So that's that one. So now I've got, this is my new expression. And that is actually something I could put in my calculator just as it is, or I could break it down into pieces. I could work out what 4 times 2 squared equals. Then I'm subtract from that this piece. So depending on how you do it, you're going to go through your calculator and come up with an answer. I'll leave that question there, but that's basically what's going on with that one. Alright, in this question we're asked to simplify this expression. I'm going to look for like terms. So what I'm going to do is, first of all, I'm going to split it into its terms, and then I'm going to look for terms that have the same pronumeral. So in this case, I can see these are 2x's, these are minus 4x's. They are like terms, so I can take those. I can take 2x's, take away 4x's, leaves me with minus 2x. And if I'm not sure of that, I could simply do the numbers. 2 minus 4, if I had to put it in my calculator, if I forgot how to do negative numbers, I could, equals minus 2. So the number becomes minus 2, and they are x's. I can also see that these are like terms. I've got 4 y's, I take a 1 y, I take away 1 y, and that leaves me with 3 y's. So that is the simplified expression. Alright, we're asked now once again to simplify an expression. These are all multiplied, they're all times. So there's no pluses and minuses, so it's just basically a case of multiplying everything right through. Always do the numbers first. So I'm going to go 2 times negative 3 times 4. And when I multiply those together, I get negative 24. Okay, you could do it in your calculator if you get stuck. So my number is going to be negative 24. Now, because I've done the numbers, I can forget about them. So let's get rid of them. And I'm multiplying the letters together. I've got an m times an m times an n times a p. Just everything multiplied together. Don't forget though, if I've got something times itself, I actually write that as squared. So that becomes negative 24. I've got two m's multiplied together there, np. That is our answer. This question is just a basic expansion question where we use the distributive law, and that means I multiply the number outside the brackets, or whatever's outside the brackets, by each of the terms inside the brackets. So I'll do two multiplications in this case, 4 times x and 4 times positive 2. So 4 times x gives me 4x, 4 times plus 2 gives me a plus 8. That's it. Okay, in this question we're asked to expand and then simplify this expression. Now, just like the previous question, I'm going to use the distributive law, so I'm going to multiply, but I'm going to do it twice. Like there's two separate parts to this, and then I'm just going to tidy everything up at the end. So let's get to it. 4 times m gives me 4m. 4 times negative 2n, so 4 times negative 2 is negative 8 with the n. Moving along now to this part, I've got 3, so negative 3 times 4m. Negative 3 times 4 is a negative 12, and don't forget to put the m in there. Negative 3 times positive 2, a negative times a positive gives me negative 6p. Okay, I've done the expansion. Now all I need to do is go through and simplify by looking for like terms. So I can see in this case, I've got a 4m, and I'm just going to split that into terms, make it a bit easier. I've got a 4m, and I've got a minus 12m. So 4 minus 12 gives me minus 8, and that was the m's that I was working with. The rest aren't like terms. I've got no other n's and p's that I can simplify, so I just leave them as they are, and that is your answer. Alright, in this question we're asked to simplify this expression. Now, a couple of ways you can do this. I'm probably going to suggest write it in its expanded form. So in other words, I could write that as minus 12. Now x cubed is x times x times x times y. Okay, don't put the times signs in. Over 3x. Now y squared is y times y. And now I can look and see if there's any things that I can easily cancel out. I can see there's a y on the top and the bottom that I could cancel out. And I could see there's 1x from the top and bottom I could cancel out. So what does that leave me with now? Well, it leaves me with minus 12 on the top, plus 2x's, so that's x squared. And on the bottom, I've just got 3y. So we're part of the way there, but now I need to deal with the numbers. I've dealt with the pronumerals, the letters, but is there a number that fits evenly into both 3 and 12? The highest common factor of those is 3. 3 fits into both of them. So how many times does 3 go into minus 12? Well, it goes 4 times, but it's a negative. Okay, so negative 12 divided. So basically what I've done is I've divided those numbers on the top and bottom by 3. Okay, so negative 12 divided by 3 is negative 4. And on the bottom, 3 divided by 3 is 1. But don't forget in algebra, when there's a 1 in front of the pronumeral, like this, we don't write it. So that becomes minus 4x squared over y. All done. Alright, we've got a fraction question, and it's got some algebra, it's got some pronumerals in it, but all the rules and laws of fractions still apply. So, in this case, I've got different denominators, don't I? They're not the same, so I can't just add or subtract them. Addition and subtraction in fractions is harder than multiplication and division, but I can make them into a common denominator. Easiest way to do that is just simply multiply those things together. 3 times 4 gives me 12. My new denominator is going to be 12. So the question I've got to ask myself, let's get rid of these, is what did I do to the 3 for it to become a 12? Well, I multiplied it by 4. And the 4 I multiplied by 3. Now, whatever I do on the bottom here, right, I have to do the same on the top. So I'm going to multiply the top bit by 4, and I'm going to multiply this top bit by 3. Now I put them in brackets just to remind me that I'm multiplying that whole piece. I hope that doesn't confuse you. So my new denominator, is 12. Let's have a look at these pieces. 4 times 4x is 16x. Okay. Minus, a daisy, right? Because I've got a minus in here. 3 times x is 3x. Can I simplify any like terms? Yeah, these two are like terms. So 16x take away 3x gives me 13x over 12, and I'm quite happy for you to leave it in that form. You could turn that into a mixed number. It could be 1 and 1x over 12. It's up to you. Alright, this time we've got another simplify fraction question, but it's going to be a bit easier because it's multiplying. So whenever we multiply fractions, it's a lot easier than trying to add or subtract them, because we simply multiply the tops, or the numerators, together, and we multiply the bottoms, the denominators, together. So let's do that. Going across the top, 4x times 3z. Well, we do the numbers first. So 4 times 3 is 12, and x times z is xz, and put them in alphabetical order rather than zx. Would be correct, but it's better to put them in alphabetical order. Going across the bottom, I've just got 2x times y, so I end up with 2xy. Now, is there anything in the pronumerals that I can cancel on the top and the bottom? There is. There's an x on the top and bottom. So basically what I end up with, after I cancel them out, is 12z over 2y. Now, is there any number that is common factor to both 12 and 2? Now, if 2 fits into 12 and it fits into 2, and it's the highest common factor. So I'm basically going to divide the top and the bottom by 2. So what do I get when I do 12 divided by 2? 6. And on the bottom, 2 divided by 2 is 1, but don't forget, we don't write the 1s in front of the pronumerals, so I just end up with 6z over y. All done. Alright, so factorizing is just the reverse of expanding. So we're going to end up with some brackets. Okay, they're like the inverse of each other, the reverse. So I'm looking for the highest common factor of each term. Okay, so I've got 3x is one term, minus 12 is another term. Is there something that fits into both of those? Now I can see that 3 fits into both of those. So I would say, oops, my highest common factor equals 3. So what do? I put the 3 out the front of the set of brackets. Okay, and I'm going to divide each of those things by 3 now. So the 3 cancels out, and all I'm left with is the x. I divide the minus 12 by 3, and I get a minus 4. So that is my answer. I've factorized it down to 3x minus 4. Now I could check it by doing the reverse, by expanding it. If I multiplied 3 times x, I get 3x. If I multiply 3 by negative 4, I get negative 12, and I'm back where I started. So I know that my answer, my factorized answer, was correct. In this question, I'm asked to factorize again, so I'm going to end up with some brackets, but I can't find anything that is obviously a common factor to both, to both terms, the m squared and the minus 64. There's nothing I can see that's a common factor to bring out the front. So what are my other options? Well, we did a thing we had called the difference of two squares, which we covered in class. So what that means is, if I've got, well, it was a squared minus b squared. All right, so two things that are squared, the difference, in other words, subtraction of one, factorizes out to be a plus b, a minus b. So if I can rewrite this somehow in something squared minus something squared, I'm good to go. And luckily, I can see that 64 is 8 squared. So I'm going to rewrite this as m squared minus 8 squared. And now it looks like that form. So I know that my factorization will have that as its answer. So it's simply m plus 8, m minus 8. I've factorized it using the difference of two squares. Alright, factorizing this question, I'm looking for common factors, and I can see that there's going to be a number that fits into that, like 4 fits into 16 and it fits into 28, so I'm going to bring it out the front. But there's also some letters that I can bring out the front here. So couple of ways you can think about this. You could think about writing this as 4 times 4 times m 3, 4, 5, 6, 7 times, right? Because that's m to the power of 7 minus, now 28 I could write as 4 times 7, and then I've got 4 m's, and I can see now that the thing that's common to both of these is I've got 4 in both, and I've got 4 m's in both. So in other words, that's the common factor. So I could bring 4m to the 4 out the front. And what goes inside the brackets now is what I need to make up each of these terms. So I can see that needs to be 4m to the 3. Because when I multiply that together, if I expanded that out, I'd get 4 times 4 is 16. m4 times m3 gives me m7. And over here, that becomes minus 7 and I don't need any other letters because I've already got the 4m's here. So my answer would be 4m to the 4 outside of 4m to the 3 minus 7. That is it factorized. If you don't feel like doing all of this, you could kind of look at the numbers and just go, all right, well, I've got 7m's up here, 4 here, so what's going to be left is the 3. Okay, so find a way that works for you, but that's the result that we're trying to get to. All right, this one down here. We're trying to get to that as our answer, and yeah. Right here I've got a monic quadratic. Monic because there's a 1 in front of the x, and quadratic because it's got the highest power of being a squared, so it's a monic quadratic. And I can know that to factorize these, if I can find two numbers that multiply to give me the negative 18, but add to give me the plus 3, they will be my factors. So thinking of the factors of 18, I guess I've got 1 and 18, I've got 2 of 9. I can't make 3 out of any combinations of those. What other factors do I have? 3 6s are 18. Now here's something I can work with, okay? I can use 3 and 6 to multiply to get this, and add to get this. But one of them is going to have to be negative. Now it's going to have to be this one, because my answer here is a positive. So when I add them together, I need to have a positive answer. So in other words, 6 take away 3 gives me my positive 3. And negative 3 times 6 gives me my negative 18. So this is the combination that I'm after. Two numbers that multiply together to give me negative 18, but add to give me plus 3. And I simply write them out in this form. I add them to brackets. So there's my negative 3, there's my plus 6, factorized with the x's. So I could check that by expanding it, not going to. In fact, let's do it. Let's do it so we can just practice expanding the gangs, or breaking up the gangs. So if I was to reverse this process now and multiply this out, I would, let's say I'm going to split this gang here. So I've got x, and I'm keeping this gang together, the plus 6. All right, my minus 3 comes down to here, and I'm keeping the plus 6 gang together. Let's expand those now. X times x gives me x squared. X times 6 gives me 6x. Negative 3 times x gives me negative 3x. And negative 3 times 6 gives me a negative 18. I've got some like terms here. Plus 6x take away 3x leaves me with x squared plus 3x minus 18, which is exactly what we started with. All right, just proving that our factorization was correct. All right, last one, and this is probably one of the trickiest ones. I've got a monic quadratic, right? Because it's monic because it's got 1 in front here, and it's an x squared, so it's quadratic. But I can't really find something that multiplies to give me this and adds to give me this yet. We're going to do that in a second, but I'm going to tidy this up a bit because I've got some like terms here. I've got a 6x and a minus ax. So I could factorize that little piece there. In other words, if I had 6x minus ax, I could factorize that and bring the x out the front because it's the common factor of 6 minus a. All right, so hopefully you can see that is just the factorized version of that. Remember when we multiply two things together, so x times this bracketed piece, I can do them in any order. So I'm going to swap them around and write them as 6 minus ax, okay, because it's just a multiplication, so I can do it in any order. So in other words, that piece is the same thing as that. So let's rewrite my equation now with this in it. I've got x squared plus 6 minus a to the x minus 6a. Now I can go somewhere with this, because now I can find something that multiplies together to give me that, but adds together to give me that. And in fact, it is those two things. All right, let's think about it for a second. 6 and minus a are my actual factors here, because if I multiply 6 and minus a, I get minus 6a. Cool, this is what I'm after. If I add them together, 6 plus minus a, and remember when we've got a plus and a minus next to each other, we just don't write the plus sign. So 6 plus minus a gives me 6 minus a. So when I add them together, I get this. When I multiply them together, I get this. So these are my two factors. So in other words, I've got an x plus 6 and an x minus a. I've factorized it. But the first step was to just tidy up this little bit, these like terms in the middle. Yeah, that's it.